throw something up in the air with an initial velocity of 25 meters per second. Positive. Can I figure out how high it goes and how long it's in the air? Is that enough information? Well, I certainly can't use this one, can I? Well, if it's 25 meters per second up here, falling, so initial velocity here is 25 meters per second. Final velocity rising is 0. Initial velocity here is 0. And final velocity here is negative 25, right? So, can you think of a formula that I can use? Because I have to use the fact that we've got an acceleration of negative 9.8 meters per second squared. Is there any formula that will tell me distance? What is it, Matthew?
I just said, isn't there one that's like VF squared equals VR squared plus AT?
Sounds good. 2AD, it's 2AD. So VF squared equals VI, and you've got to have your formulas in front of you probably, plus 2AD. So I can use either one of these. It doesn't matter. If I use this one, then I'm going to have VI is 25, and VF is 0, and G is still negative 9.8, right? As long as we agree that we're always going to make it negative, here I could have VI is 0 and VF is negative 25, and G is still negative 9.8. It's going to turn out to be exactly the same thing all the time, right? Except this will give me a negative distance and this will give me a positive distance. And so a lot of times I just, you know, I know I want a positive distance. So I just kind of ignore the negative on the 9.8, right? Because I know I want a positive distance. That's the only time I would ignore it. But if we don't ignore it, it's still going to work out, okay, right? So if I don't ignore it, I don't care what we use. I could use VF is 0. So 0 squared equals 25 squared plus 2 times negative 9.8 times V. Well, 25 squared is 625. When I subtract it from both sides, I get negative 625 equals negative 19.6 D, right? Divide by negative, we're going to get a positive. And if I had chosen this one, I would have gotten a negative because it fell. But since we want to know how high it goes, let's just choose this. It'll turn out to be positive. And then time, you know, final velocity equals acceleration times time. So time will always be the velocity from which you relate, you know, the velocity you release the ball divided by 9.8, always. That's the time to go up. So if I ask how long it was in the air, I don't know, what is 625 divided by 19.6? Anybody work that out?
Let's see it now.
And this will happen when we get into projectile motion and all that stuff. I don't know, what is that? Anybody do that? 31 point what? 89 or 31.9 meters high. Right? We do an experiment. If we ever get really nice weather, we go out when we get projectile motion, but I don't know. Hopefully we'll get one day of nice weather, we can go out and take some measurements. Okay. Anyway, and then if I want to find out the time in the air, time will always be, for something falling, will always be final velocity divided by G, right? Because acceleration. Final velocity is acceleration times time. Assuming VI is 0, and then just divide both sides by acceleration. So it's going to be 25 divided by 9.8. Technically, it's negative 25 divided by negative 9.8, right? Because we're falling 25 meters, and acceleration is negative 9.8. And so that would be 2.5 something or 2.6. 2.6, round it off. But that's just the fall, right? And here's the mistake that some of you are going to make, hopefully not, is that you're going to write 2.6, but that's just how long it took to fall. We have to double it, right? It's also going to take 2.6 seconds to go up in the air. So the total time equals 2.6 seconds times 2, 5.2 seconds. So it'd be in the air for 5.2 seconds. Did that help or did that confuse you? I wasn't sure. There's another worksheet that we just published on